Hello, everyone. If you need to compare two query plans based on their CPU usage but not I/O, here is an example. Let's say we have three tables, and these tables have a different number of tuples. Project table has 100 tuples, commits table has 50,000 tuples, and developer table has 250 tuples. When we are comparing two different query plans, we are going to also have to find out what kind of selection criteria there are and what kind of join operations that we have in these query plans. So for the purposes of demonstration, we are just going to look at the relevant columns and the statistics that we can use to create and compute the CPU time required for running these query plans. So for the project table, the programming language column has 10 distinct values. And for the developer table, we have ranks ranging from 1 to 5. That means 5 distinct values. Let's see how these compare. Okay, let's compute how many intermediate results we will have for the first query plan. The first query plan will scan 1,000 tuples for the project table, 50,000 tuples for the commits table, and 250 tuples for the developer table. This first selection criteria, the programming language R, if you remember, we have 10 distinct values in that column in those 1,000 tuples. So it's going to, we are assuming a uniform distribution here because there are no other statistics that have been given to us. So for programming language R, the selection criteria will roughly return 100 tuples for us because there are 10 distinct values in the programming language column. And then for the join operation, now we are eliminating about 9/10 of the tuples that is given to us. So for out of 50,000 tuples, we are multiplying it 1 divided by 10. That gives us 5,000 tuples returned by the join operation. Now let's look at the other side of the query plan. There are 250 developers and we have 5 distinct ranks for the developers. So again, since there are no other histogram distributions are given to us, we are going to need to assume uniform distribution. So for rank 2, we are assuming there is going to be roughly about 50 developers. Now, again, when we are joining these, we are going to have to multiply by 1 divided by 5 for 5,000 tuples, but that doesn't interest us. That is not interesting to us for query comparison. That's just going to compute how many results that we will have, which is irrelevant for query cost because we are looking at the inputs for this last operation here. And then for the second query plan, we are going to start from the left. For project scan, we are going to scan 1,000 tuples, and the selection criteria again will eliminate 9/10 of all the 1,000 projects. So that's going to give us 100 projects that is programmed with R. Again, we are assuming uniform distribution. Now we are going to look at commits made by developers. So we already remember there are 5 different ranks and we are assuming uniform distribution. So that's going to give us 50 different developers. 50 different developers means that we are going to divide 50,000 commits by 5 as well. That's going to give us 10,000 different commits for developers ranking 2. Now we also have the intermediate, we have all intermediate results that we need. So how do we compute the intermediate result size and compare the two queries? So for plan 1, we have 5,050 different intermediate results. When we sum them up, we have 5,150 intermediate results. For query plan 2, we have 150 and 10,000 intermediate results. That gives us 10,150 intermediate results. When we compare them to 5,150 is lower. That means query plan 1 is better.